I have a couple minutes, but if you guys want to start early, I'll start early. Yeah? All right. Whoever's not early, too bad. Okay, so my name is, can you guys hear me okay? Sure? All right, yeah, my name is Islam Sharabash. I'm a full stack developer at DataHero. We do data visualization on the web, so you either import data or you upload files, and then we give you pretty graphs and charts. So for that, we use Node.js, and so I'll get into a little bit of the problems you run into. So show of hands, who uses Node? Good, so like most of you should. And then, so the problems you run into with the event loop. So yeah, with that, I'll get started, and then I'll show you the solutions to those problems. Because problems by themselves is not very fun. So yeah, our agenda today, we're going to talk about like problems you get with the event loop, solving those problems with the AsyncListener API, and then what the AsyncListener API is, how it works, because as an engineer, you need the kind of lower level understanding to know what trade-offs you're making when you choose to use something. Cool. So yeah, the problems we're going to cover today is having a request ID propagate throughout the code. And so I'll jump into these specifically later. But the general overview is having a request ID propagate throughout the code. So what this is you want like a unique identifier, and you want to assign it to a web request that's coming in, and then have it available everywhere. So this might be a user ID, but for this instance, we'll say generate unique identifier and then pass that through. And then the second one is having short stack traces from asynchronous functions. So did anybody see Bert's talk yesterday? Bert Belder? Yeah, so remember that like e-connection reset? You don't need to use zones for that. There's actually solutions you can use today to get like the full stack trace and not have that problem of not knowing where your errors are coming from. And you can use them in production. Cool. And then the third thing is profiling asynchronous functions. There's ways to make it easier. So all these problems are inherently related to the event loop, and so we'll talk a little bit about where they come from with respect to that. So request ID. So essentially, this is you want this unique identifier. Here it's RID. So this is a naive solution. You want some identifier, and you want it available everywhere. So if your application is small, you can do this, which is pass it everywhere. And I actually talked to somebody this morning, and this is what they do because their application is really small. But as soon as your application becomes larger and you have more modular code, you don't really want to pass it everywhere. So you can see like we're doing a user.save load and like sending off an email, and we're passing this context object everywhere. So some people use the request object for this, but as soon as you want to keep things self-contained and not have everything know about the request object, this no longer works. So it's startling. Yeah. The second thing is short stack traces. In short, you have asynchronous callbacks, right? So you're saving a user, you're loading it up again, then you're sending them an email. And then your error handling is just like this returning of the errors, and you're not doing anything special there. So do any of you guys actually do error handling like that? Just like pass it up the chain? Right, you should be like passing it up somewhere or handling it somehow. And so if you do that and you get an error, it doesn't really tell you like where it came from. So you see this parse error here, but all it goes is to the TCP on read. And so Bert's talk yesterday touched on this. They said all you get is this like e-connection reset, and nobody knows where it came from. Yeah, it's not very helpful, but there's things you can do today to get the full stack of like where these errors are coming from. Sure. So if you tried to debug from this, I have more animal pictures, so it'll be okay. And then third thing is profiling asynchronous code. So here's an asynchronous function, right? So here you are setting a timeout and calling a callback. If you want to time how long this takes, you can do something like this. And notice the lines of code. Here you have 3, here you have like 10. That's not super great. So here we're just like wrapping that function, replacing it with something that'll start, measure a date, and then do a time diff. You can do that. It's not super great. So this is like the third class of problems that all come from this event loop. So where do they actually come from? Callbacks. So what Node affords you is that it lets you make your code asynchronous, and it kind of forces you to make it asynchronous. But with that power comes the responsibility of like not knowing where the previous tick went or where it's coming from. So what this actually looks like is, say this is your asynchronous lifecycle. So process.nextTick myfunc. So myfunc is your asynchronous function, right? So you call process.nextTick so that myfunc is going to get handed over to the event loop. And then the next step is on the next tick, myfunc is going to be executed. All right? So after it goes to the event loop, you lose state and you lose some stack. So for the short stack traces example, what's happening is that by the time myfunc is executed, that stack is already unwound. So that stack is not even present for you to use. And so that's why you can't have a stack trace. So things go to the event loop, and that's kind of small. It's a picture of Mount Doom. So it's like where things go and never come back. Right, so this is remember this image though, of the life cycle of myfunc getting handed over to the event loop and then executed later. We'll talk about what the async listener lets you bypass that. And yeah, so we're going to do that with the async listener API. So the async listener API is actually really simple. You create listeners, you add them, and you remove them. So it's 3 different calls you can make, and then it's available in Node 11. How many of you guys use Node 11? All right, so good, because there's actually a polyfill that backports it to Node 8 and Node 10. Do any of you guys use New Relic? Yeah, so you already use it in production, because New Relic uses this under the hood. So it's like battle tested, right? So what is the async listener API? So remember this image of the life cycles of our asynchronous function. So you call process.nextTick, it gets handed to the event loop, sometime later it's executed, and then sometime even later that function either returns or errors. So what the async listener API allows you to do is assign callbacks to be called when those lifecycle events happen. So you can have some arbitrary code run when that function is handed over to the event loop, and then you can have it run before that function is executed, and then after it's executed. And so by being able to tap into that lifecycle, you're able to do a lot of really powerful things that you couldn't before. So let's cover that. So let's go back to the first problem of propagating the request IDs. So how are we going to actually do that? So we're going to not use the async listener API directly. Instead, we're going to use a module called ContinuationLocalStorage. And so this is built on top of the async listener API, and what it allows you to do is basically have like a little bag of data that you pass around to all your asynchronous functions. So general overview of what it is that you have this asynchronous function. And so remember our chain before of like users.load and then users.save and then sending that mailer. This would be the same chain of asynchronous functions. So when you use continuation local storage, it gives you this like little bag of holding that you can put stuff in and you can take things out of. And so that's really powerful because now when you have that chain, the other functions get that same bag of holding. So then now they can set things in it and get things out of it. And then every chain gets a different bag. And so this is essentially what we're going to use to store our transaction IDs and pull them out again. Cool. So when we want to propagate these request IDs, we want it to be easy. And then for this example, we want to pull it out when we do a log message. So let's go to code. Right. So here's a log message, timestamps message. And then what we actually want is this. So we want timestamp message and some request ID. So you can see it's just an arbitrary string, but you can see the first and the third log messages are related, and the second and the last one are related. Sure. So how do you do that? So we're going to do that in 3 parts. We're first going to create a continuation local storage namespace. Why that's important is because you might have other modules that are using it. We'll get into what this is. But essentially, like because New Relic uses it, and you want to use it, you don't want to squash each other's values, right? So you create a namespace such that you're not going to squash each other's values. Because if you say, oh, save this transaction ID and new Relic does as well, you want to know which one you're actually trying to access. Then we're going to create an express middleware to create the request ID and assign it. And finally, we're going to look it up when we're writing our log messages. So creating a namespace, you call create namespace with a string. You can use a reverse URL. Sure. So you just do that once at the top of your application when it boots up, and that's it. In your middleware, you're going to use get namespace, so that'll get you the same namespace that you just created. So we're just requiring our stuff here. And so namespace is now the com.DataHero namespace. And finally, this is like the meat of it, right? So this is our middleware. And what we're going to do is we're first going to create this request ID. So it's a unique identifier. Then we're going to call this bind emitter. So what ContinuationLocalStorage will do for you is automatically when you have this like callback chain that's kind of down there, it'll automatically say, okay, these callbacks are all associated with this same namespace, but for emitters, you have to do it explicitly. And then we call namespace.run. And so at this point, remember each web request is going through here. This is going to create our actual little bag to store and get values out of. So because every request goes through a middleware individually, every request will call namespace.run, and then you get that little bag for the rest of the requests downstream. So every asynchronous function called inside this callback will be able to access that same namespace and those same values. And you can just call setters and getters on it. So up here, we created that unique identifier. Down here, we just set it. We're putting it in the bag, and then we call next. And everything downstream will be able to access that. Good so far? Cool. And then something downstream might be our logger. And so our logger, we get the namespace, and we can get the request ID out of it. So if you remember the first example where we had this context object that we were passing everywhere, you essentially bypass that, and you no longer have to do that. And you can still access the request ID as you did before. Cool. So second example. Yeah, happy cat. Second example was short stack traces. So remember that this was essentially the problem, right? So you had this series of callbacks. Somebody threw an error. You have no idea where it came from. So the solution to this kind of looks like this. So this is our life cycle of the asynchronous function. When the function becomes asynchronous, when it gets created, we're going to save a copy of the stack trace at that point, because that stack is going to unwind. And then later, when an error happens, we're going to stitch those stacks back together. Okay, but the great thing is you don't actually have to do that. So there's a module out there built on the AsyncListener API called Stackup, and you just install it, require it, and you're done. So that's what it's doing under the hood, though. So whereas before you might have just let that stack go and be garbage collected, you're now keeping that around to stitch it on demand. Third problem was profiling asynchronous code. As before, we're no longer going to wrap the previous functions. Instead, we're just going to record the time when the function is executed, record the time when it finishes, and then calculate the difference. Once again, you don't need to do this yourself. There's a module for it. It's called async profile. The use is pretty easy. You just require it and then create a async profile, and then when the process exits, it'll dump it out. Yeah, so in summary, there's these inherent problems that you get when you're using an event loop, like the stack trace is gone, or you don't necessarily it's not necessarily easy to carry values throughout. And so with the AsyncListener API that's coming out, you can really simplify a lot of that and yeah, prepare for more tracing packages. So as this becomes more standardized and more out there, you'll see it built into a lot more things. Yeah, so if you have any questions, we're also hiring if you're interested in Node. I don't know. I think some of you use Node. Cool. Are there any questions about this? Go for it.
Yeah, so you have all this thing with namespacing and the rest. When you have a function that's going to be in a callback, you can always attach data to it, right?
When you have a function that's going to be in a
You've
call.
got a function's an object. You can always
Mm-hmm.
throw this bag of data onto the function.
Sure.
Doesn't that take care of the namespacing? If you attach the data directly to the function.
Right. So under the hood, what continuation local storage is doing is for every namespace, it creates a different set of contexts for that. So.
But the namespace is basically being used to isolate that function from everything else, right?
It's being. It's modular. So it's being used to isolate your set of values from everybody else's set of values. Okay. Yeah.
So for example, New Relic uses continuation local storage, and you don't want your stuff uploading New Relics.
Yep.
So that's what
Yep.
Is there any performance consideration of using this, or should I just stick it on every?
Sure. So under the hood, the polyfill is actually patching where the calls into the event loop go. So to be honest, it depends on your application. So I'd recommend testing it out and seeing whether it works for you or not. So like I said, if you're using New Relic in production right now, you're already paying that performance penalty if there is one. So we use it and it works fine for us. So I'd recommend just giving it a try. With the stack traces, you are keeping that extra stack trace around, so
Right, yeah.
there might be, but.
What do you think if already using New Relic, creating another namespace, doesn't that another penalty, right? Or would it?
It's probably pretty minimal. Yeah. Any other? Sure.
Yeah, I don't want to troll you too much, but are you actually using it for SQL queries, as you showed in
We're not using it for SQL queries, so we're right now using it for log statements and getting that transaction ID throughout the request ID.
Oh, so here's the thing, which is not very widely understood. There's an issue with this concept, which is very often what you will have, for example, in Node, the database driver, and it will take database queries, but it will pull that all to one connection.
Mm-hmm.
Now, when the database sends data back, your the continuation local storage that you get is associated with the time that the connection was created and not the particular query that you sent. So I wonder if you found a solution.
Sure. So something I didn't mention is that for the things that pull it, so Redis does the same thing, there's CLS modules that you install that'll patch them as well. So in certain scenarios, when you're calling out to services that do that, you'll need to explicitly assign your callback. So for example, with our MySQL connections, they all go through the same function, and then before we say, okay, namespace.bind this callback, and then later it's able to look up the correct namespace. So it's not all fun and games, but with a little bit of tweaking here and there, it actually works pretty well for us.
Do you do that manually in your code before handing it over to MySQL, or do you kind of patch it?
Do we?
Do you patch it in MySQL code, or do you?
Sure.
Or do you
So,
wrap the callback before sending it in?
Right. So we wrap, for MySQL specifically, we wrap the callback before sending it in. For Redis and for, I think the other one is Bluebird. For other modules, there's CLS modules that you can install that'll patch it for you. Any more questions? Cool. Thank you, guys.